So, oh, excuse me. All right, we'll start off with number 8 here. So number 8 is kind of just a review of what we did yesterday. So we're multiplying the rational expressions here. So we're going to start off, though, by stating the excluded values. And so remember, we're not allowed to have the denominator equal 0. Now, in this case, we have two denominators. So I have to say here that 3x squared cannot equal 0. And also, x squared plus 17x plus 72 cannot equal 0. All right, now the 3x squared cannot equal 0. You can divide that by 3 and square root it. Or we talked about a lot yesterday, whenever you have something that's like no adding or subtracting, when it's just multiplication and exponents like this, we can always just say that means x cannot equal 0. So that's a fine little shortcut there that I'm okay with. All right, now for the other one, though, we're going to need to factor it. So I got to think of two numbers that multiply to 72 and add to 17. So multiplying to 72, 8 and 9. Does that work? Yep, 8 and 9 makes 17. So now I'll rewrite this. 8x plus 9x plus 72. And we get x squared plus here. And then we'll do the grouping. First group I can take out an x. Second group I can take out a 9. So I get x plus 9 times x plus 8 cannot equal 0, which would mean x cannot equal negative 9. X cannot equal negative 8. So I actually got 3 excluded values there. I got 0, I got negative 9, and I got negative 8, okay? All right, now we'll go ahead and simplify this. So to simplify it, we're going to need to factor the bottom right piece, but good news is we already did factor it, so I can just bring that over. So I'm going to write that as x plus 9, x plus 8 there. And then we can actually also factor the top left piece with a GCF. So both of those can divide by 9. So I'm going to take a 9 out front and call this x plus 9 in there. It's like reverse distributive property there. All right, and let's see what we can cancel out here. All right, so we can cancel out x plus 8 with x plus 8. We can cancel out x plus 9 with x plus 9. Remember, we can always cancel top to bottom, even if they're not part of the same fraction, as long as they're multiplying. And there's actually one more thing I can partially cancel here. The 9 and the 3, I can divide those by 3. We're going to reduce it by 3. So that's going to become 3 on top and 1x squared on bottom, which I would just write that as 3 over x squared. All the other parentheses got crossed off, so that's my final answer there, 3 over x squared. Okay, let's move on to number 9, and we're going to switch topics here. So let's make a little note up top. So what we're switching to here is actually, now you can see, is division. So for division, here's what we're going to do. First of all, find excluded values. So we definitely want to do that first, which is what we've been doing first. So we're going to say the denominators cannot equal 0. And then the second thing we're going to do is flip the second fraction. And it turns into multiplication. Flip the second fraction and it turns into multiplication. So then it just turns into these other problems that we've been doing before, where we can cancel stuff out from top to bottom, but we're only going to do that after we flip the second fraction, okay? Very, very important. All right, so number 9 then. I'll give you another 15 seconds to write that down. So once again here, it says find the excluded values, first step. Second step, flip the second fraction and turn it into multiplication. Or it turns into multiplication. Okay, so I see on my denominators here, I have the, in both cases, I have the variables with no adding or subtracting. And so we kind of have been talking about here that you can always, for those ones, just say that that variable cannot equal 0. If you want to set them equal to 0 like we did yesterday, you can, but that's a good shortcut here. Okay, but now to simplify it, my first step is going to be to flip the second fraction. So I'm going to keep the first fraction the same. And then I'm going to flip the second fraction. And once I flip that second fraction, the division turns into multiplication. Oh, I messed up here. That should be 2r to the 5th. Okay, so now we're going to look at this like multiplication, so I can cancel anything down. I see, let me zoom in a bit here. I see I have the 10s here. I think that would be the easiest thing to just cross them off, because a 10 is like a perfect cancel with a 10. Once again, even though they're not on the same fraction, as long as it's top to bottom now that we're doing multiplication, you can cancel them out. All right, the 4 can partially reduce with the 2, so that'll become a 2, and that will become a 1 if I divide them both by 2. The r's here I can partially cancel, so that's like my battle, I always say. So the bottom's going to win the battle by 3. All right, over here, now I have left a 2r, I have a 1 on bottom. Now, I noticed that I actually, when I wrote everything, all the leftovers down, I noticed that I can actually still cancel something out, okay? So I'm going to do that. I see that I have r to the first up here, and I have r to the third on bottom. So I can cancel those out. This one's going to go away, and the other one will become r squared. So kind of always do I've been doing that double check. I don't think we've come across any where we've been able to cancel further, but in this case, you can see we were. And so now I can just do top times top up top and bottom times bottom on bottom. There we go. All right, let's head over to number 10. We'll start off with our excluded values. Once again, we have variables in the denominator on both of these with no adding or subtracting. So that always tells me x cannot equal 0. So I'm just going to use my shortcut there. Now to simplify this, my first step, remember, is going to be to flip the second fraction and then turn this into multiplication. All right, now we're going to cancel out whatever we can. I say I can cancel out these x's here for a clean cancel. I could have canceled out this x attached to the 7 with the 3 down there, 3x, or with the x down there with the 3 as well. Either way, it's going to come to the same thing. The 10 and the 6, I can both reduce by 2. I can divide by 2. So that's going to become 5 and 3. If I divide those both by 2, I don't see any other numbers I can cancel out. Remember, I cannot cancel the 3's out because it's not top to bottom. They're on the same level, correct? So it'd have to be top to bottom. So what do I have left over here? I have 5 over 3 over here because I canceled out the x's. I have 7x over 3 on the other fraction. I don't see anything else. Doing my double check, I can cancel out. So we do top times top up top, bottom times bottom on bottom, and there we go. Okay, next up here on number 11, we really need to make sure on this one that we find our excluded values first. This is definitely a case where after we flip this, it's going to kind of change what's on top and what's on bottom here. So I need to find my excluded values first before I flip it. So I'm going to go ahead and factor this a squared minus 4a minus 45. So I'm going to think of two numbers that multiply to negative 45 and add to negative 4. So if you can think of those, go ahead and write it down. Okay, I got 9 and 5. If I make the 9 negative. So I got a squared minus 9a plus 5a minus 45. Can take out an a here, leaving me with a minus 9. Take out a 5 here, leaving me with a minus 9 again. So I have a minus 9, a plus 5 cannot equal 0. So we know a cannot equal 9 then, and a cannot equal negative 5. If I look at the other denominator over on the other side here, a plus 5, I see that I kind of already have that one accounted for, right? I already said that a cannot equal negative 5. That was one of my parentheses over there, so I don't need to write it again. It's already done, okay? Now it's time to simplify this. So my first step should be to flip the second fraction and change it into multiplication when you do that. All right, now we need to factor the top right piece. Good news, we already factored it right here. So that's always nice. I'm going to cancel stuff out in a second, but I'm going to slow down in case I'm going too fast here. All right, so the only thing I see I can cancel out is the a plus 5 here. So really I have 1 over 1 times a minus 9 over a plus 10. I don't see anything else I can cancel out. I'm not allowed to cancel these a's down because they have adding and subtracting to them. And so just kind of think of those being in parentheses. So when you have like an A plus or an A minus, you always you have to cancel that out with a parentheses that is the exact same. All right. All right, a few more here. Number 12. Okay, so number 12, we'll do our excluded values first. So we know 4x plus 16 cannot equal 0. We know x plus 3 cannot equal 0. This one's going to be x cannot equal negative 3. But this one is not negative 16 because it's the 4x there. So we're going to have to actually show our work on this one. So be careful whenever you have a number in front of x. It kind of makes it a little more complicated. If it's just x plus or x minus, that's fine. Just do the opposite. But in this case, we got 4x plus 16, so we subtract the 16 and then divide by 4. All right, for my factoring here, actually, no, before I factor, I have to flip the second fraction, change it to multiplication. The only factoring I can do is I can take out a 4 down there on bottom. So if I GCF the 4, I'm left with x plus 4. I can cancel out these 4s here. There's nothing else I can cancel out, so I'm just going to get x plus 3 over x plus 4. All right, next up, number 13. Almost done here. Stick with me. Just 2 more problems to go. So I need to find my excluded values first. So I know I'm going to have to factor this one. Okay. So I got to think of 2 numbers to multiply to 16 and add to negative 10. So that's going to be negative 8 and negative 2. Do my grouping there. First group I can take out an n, which leaves me with n minus 8. The second group I can take out a negative 2. Remember, when you take out a negative, you switch the signs, so it'll become positive n minus 8. So we have n minus 2 times n minus 8 cannot equal 0, which means n cannot equal 2, n cannot equal 8. However, in this case, the n plus 3 over here is actually going to give me another excluded value, n cannot equal -3. We saw in a previous one that n plus or n minus, that other parentheses, was already included in my factoring. In this case, it's not. And so I need to put that as an excluded value since it is in a denominator. Even though I'm about to flip that denominator, it still carries over. Okay, so now I'm going to flip the second fraction now. So it's going to be n plus 3 over 1. We do that anytime it's division. And now we turn it into multiplication. I'm going to rewrite this one, but when I write the bottom, I'm going to write it in the factored form, which I'm getting from my work over here, right? So, yep, factoring obviously a kind of super important part of this whole process. So just make sure when you're factoring, you only have to do it once on each expression. So if you already have it factored somewhere else, don't factor it again. Looks like I can cancel out the n minus 8 there. So I'm left with n plus 3 over n minus 2. And that's it. All right, 15 more seconds and then we'll move on to our last one. If you want to start looking at it and thinking about it, you may. All right, let's go for it. All right, so let's do our excluded values first. Now, 9r to the third minus 36r squared cannot equal 0. That does have some subtraction, so I got to factor that. So I'm going to take out 9r squared. I can factor that out front. And that just becomes r minus 4. So that's a little GCF there. Both of those can divide by 9, and we can take an r squared out of both. So that turns into just 1r and then minus 4. So this one would say r cannot equal 4. This one out front is going to say r cannot equal 0 because we have that variable out there with no adding or subtracting now. That's one of our 0 ones. And then I also have r cannot equal 5 for the r minus 5 on the other denominator. All right. So now I'm ready to simplify. So I'm first going to change the second one, flip the second one and change it into multiplication. I never flip the first one, but when I write the bottom, I'm actually going to write it in the factored form from what I did over there. So we're going to go 9r squared times r minus 4. And I hope you see why I wanted to do that, because now that that's out front, I can cancel out this 9 with that 9. And I can actually cancel out the r squared with the r squared as well. So all we have left is r minus 5 on top and r minus 4 on bottom. Awesome.